There are a large variety of types of motors. Motors are described by how they are mounted. The most common mounting is horizontally on feet or mounting pads, as you see here on the motor to the right. There are also vertical mounted motors, like the motor on the left with the motor output shaft in a vertical orientation. Motors are further described by their enclosure type, which we will delve into further. We should first go over what is called the motor frame size. The frame size is shown right on the motor's nameplate. Frame size is a standardization of important physical dimensions of motors that allow interchangeability. Frame size makes it possible to replace one brand of motor with another with the same frame size rating. You can find a frame size chart in the Technical Resources section on wiredmotorsinc.com under NEMA frame sizes. NEMA is the National Electrical Manufacturers Association, and this body has established various standards such as frame sizes to which their members manufacture their motors to meet. Over many decades, as motor materials and manufacturing methods have improved, NEMA has changed the frame size designations 3 times. For more than 40 years, the current frame size standard is known as the NEMA T-frame. So you will see a T after the frame size on a motor nameplate. For example, you will see a 256 T-frame on a modern motor. Prior to the T-frame designations were the NEMA U-frame sizings. For example, a 256 U-frame. U-frames are physically larger than the current T-frames, so you cannot expect to replace a 256 U-frame with a 256 T-frame. You can buy what are known as transition bases, which mount to the bottom of a current T-frame motor to convert this 256 T-frame to mount in place of a 256 U-frame. And there are a few of the most common U-frame motors still made by some motor manufacturers, such as Baldor. The last but now very rare frame size is known as the pre-NEMA frame, which predates back to 1952. Being able to use this frame size standardization has greatly simplified replacing a motor. As long as you buy a replacement motor with the same frame size number, you can be assured it will physically have the same exact mounting, drive shaft location, diameter, and keyway size. Your new replacement motor will just physically mount into the same place. Except for one big warning. There is no standard for overall length and width. Neither the overall height nor width sizes are standardized by the NEMA frame callout. So if the location of the motor is going into a very tight space with little room around the motor, you need to physically match the overall width and height of the motor to the tight space it is going into. Usually motors are located in very open spaces. But if you have other equipment, walls, or enclosures that are impinging on the motor's location, you would want to measure the available space for the motor and make sure that the motor will fit into that space. You will need the overall width and length for the motor you are purchasing. When purchasing a motor, one of the most important factors in the type of motor you need for the application is the motor enclosure. The motor enclosure design provides 2 criteria: protection from the environment and thermal cooling or heat exchange. These 2 criteria, environmental protection and cooling, are dependent on each other, as you will see. The 2 most prevalent enclosure types are named open drip proof and totally enclosed fan cooled. Open drip proof, also known as ODP, has a motor cooling exchange that flows external ambient air directly over and through the interior of the motor. The rotating element inside the motor has fins that cause a pressure displacement that causes external air to flow into and over the internal motor parts, such as the electric motor windings, and then exhaust out of the motor. This open drip-proof design is both efficient in cooling and electric usage, as well as lower in purchase cost. However, because you are flowing external air inside of the motor, over exposed windings and internal mechanical rotating parts, it requires that the external air be very clean, dry, and free of chemical contaminants such as oil vapors and the like. Any materials or moistures contained in the external cooling air will be deposited inside the motor, causing a short motor life. This ODP type motor is good for interior clean locations such as on compressor motors, refrigeration, machine tools, and pumps. ODP motors are not good candidates for outside installations exposed to rain, blowing dust, or any high humidity or chemical vapors. The most broadly used enclosure is the totally enclosed fan-cooled, which is also known as TEFC. As this enclosure's name implies, the interior fragile components of the motor are totally enclosed and protected from the outside environmental contamination. The motor is cooled by an externally shaft-mounted cooling fan that blows external ambient air over the motor exterior surface. And on the higher quality motors, the cooling air moves through integral heat exchanger fins as seen in this motor. These external fins or ribs act to increase the surface area, which aids in greater cooling effects. The weaknesses of the TFC design are greater initial purchase costs, uses more electricity, heat exchanger fins need to be kept clean, intake grill of the fan cover must be cleaned to maintain cooling, and the drive-in bearing is not as efficiently cooled as with the internal cooling flow of an ODP design. But the TFC motor can be used in a wide variety of environments and is well protected from all environments and is well suited for a dirty, humid, interior or exterior environment. Another very common motor type designated by its mounting method is the C-flange motor. As seen in this photo, one end of the motor has a machined flange and threaded mounting bolt pattern. This C-flange type motor comes in two configurations. One design comes with its own mounting feet, and the equipment that this motor drives, such as a pump, are mounted onto its C-flange. The other C-flange configuration comes with no mounting feet. This footless C-flange motor is mounted and hangs on the equipment it drives and relies on the driven equipment's base mounting. There is a NEMA frame callout and size standards for the flange and mounting bolt pattern. The NEMA frame callout for a C-flange motor is simply designated by the letter C. As an example, if you saw a 256TC on the nameplate frame callout, that would designate this motor has a C-flange mounting configuration. Another common motor type that can trick you because it looks similar to the C-flange type motor is the close coupled pump motor. While this type motor does have the same C-flange machined mounting, it is very different due to its special shaft. There are two different types of close-coupled pump motors that are defined by the seal design used in the pumps these motors run. The upper motor in this photo is used to run a pump with a mechanical seal design. Its shaft is shorter or stubbier. The lower motor in this photo is used to run a pump that uses a packing seal design for sealing the pump fluid from exiting the pump. Its shaft is much longer to accommodate the pump packing area. You might ask, how the heck am I supposed to know the differences by a knowledge of these shafts? Well, you don't. Once again, the NEMA frame rating on the nameplate and in catalogs tells you this. For example, with a 256JM frame rating, the J means this is a close couple pump motor, and the M callout tells you it is a mechanical seal type closed coupled pump motor. So to replace it, you would simply specify another 256JM close coupled pump motor. If the NEMA frame designation was a 256JP rating, then once again the J means it is a close coupled pump motor, and the P part of the 256JP frame designation tells you it is a pump packing seal close coupled pump motor with the longer shaft. So you would specify another 256JP frame motor in our example. Yet another trick that can fool you when it comes to what looks like a regular old C-flange motor type is a variation called the D-flange motor. The D-flange motor also has a machine mounting flange, but it is actually much different than your garden variety C-flange. The D-flange motor is used in larger compressor motors or other heavier loading applications. And once again, the great NEMA frame designation comes to the rescue. If you see a frame rating with a D in the end of the callout, it is telling you that a D flange motor is required. For example, you have a nameplate with a frame callout of 404 TD. The D is telling you that you have a D flange motor type and must maintain that in the new motor. So don't get fooled into looking at the motor and thinking you just have the common C flange motor. These are the most common day in and day out motor types you will run across. There are many others such as explosion proof, WP1 and WP2, air over, water cooled, DC motors, and on and on. We will be providing a future video on these more specialized motors, but now you know the most common motor types.